Okay, we're going to do more of Test 3's review. I'm going to do page 2 and most of page 3. That'll be number 7 through number 14 on your review. Let's start with number 7. They're asking you to graph this function. So let me put the function in here first. And then we've got a graph. We're going to use this graph. We'll worry about it in a minute. First thing we need to look at is the different zeros. So we've got a 0 here at -1. Remember, this is a liar. All of these are liars. So we've got a 0 at -1, and that's going to happen just once. Happens once. We've got a 0 at -3, and again, because it's raised to the first power, it's only going to happen one time. And because it only happens one time, it's going to cross the x-axis. It's going to go screaming through the x-axis. The last one, the x is at -5, and because it occurs twice, it's going to bounce when it hits the x-axis. It's going to bounce off of it. Let's see, we need to figure out what the end behaviors are going to do here. This is an x plus 1 to the first. That's an x plus 3 to the first. And that's an x plus 5 to the second. So 1, 2, 3, 4. This is finally an x to the fourth function. That's an even number. So you know it's going to behave like a parabola. It's going to go up on the left and up on the right. And we don't have a negative in front of it, so they will go up. So let's see what we can do about graphing that. Let's see. We've got a -1. We've got a -3. And we've got a -5. And remember, it's going to bounce there. So I put a B there, just like in class. We know the end behaviors are going up to the left and up to the right. So we're going to come through here. This is our -5, 0, and it's going to bounce there. So let me bring it in and have it bounce up. It's going to go up here somewhere. I don't know exactly where, but it's going to have to come back down to cross through the -3. Goes crossing through, and it's going to have to come back up to cross through the -1, 0, and then on its way out to infinity. So that's what the graph will look like, close enough. And that's what you need there. Okay, so let's move on to number 8. Number 8 and 9, you're asked to do synthetic division. So let's see, number 8, we're looking at x to the 4th plus 3x to the 3rd plus x squared plus 7x plus 4, all of that divided by x plus 1. So if we're going to do synthetic division, remember this is attached to an x plus or an x minus, so it's a liar. So the real x, remember you're imagining if you're setting it equal to 0, so it would become a -1. So I'm putting a -1 in the box, and then I'm grabbing the coefficient for each of the terms. So 1, 3, 1, that's a positive 1 there, 7, and 4. Build your line there, bring this guy down, multiply, add together, multiply, add together, multiply, add together, and multiply and add together. So remember, this is going to be our remainder, and these guys will each be 1 degree lower than what we started with. So we started with x to the 4th. This will be 1x to the 3rd plus 2x squared minus 1x plus 8, and then we've got that remainder, 4 over, and we use our original denominator, x plus 1, and that's the answer. And that's all you're asked to do in number 8. Number 9 is similar. -4x to the 3rd minus 22x squared plus 7x minus 30 all divided by x plus 6. Let's do the same thing. Let's grab, this is a liar, so the number that is the 0 here is a negative 6. And then we're going to pull each of the coefficients off of each of those terms. Bring this first number down and multiply. Subtract. Multiply those two. Subtract. Multiply those two, and that zeroes out. That's wonderful. That means there's no remainder. And you know that each of these terms is one decreased from the thing we started with. So we've got negative 4x squared instead of third, plus 2x minus 5. And that's what we get when we divide the cubed, this big old guy, by x plus 6. We get that as our answer. Let's move to number 10. Here the function is 9x to the 4th plus 3x third plus 2x squared minus 4x plus 32. And it's asking you to use synthetic division and the remainder theorem to find the indicated function value. Well, the indicated function value is f of 4. So they're asking us to find f of 4. That means what we want to do here is we want to do synthetic division with 4. 9, 3, 2, negative 4, and 32, just like we have been doing. And remember, what we know is going to happen is that what we get right here for the remainder will be what you get if you plug 4 in for x, plug in 4, plug in 4, plug in 4, and add those all up. So we're going to do this in a sneaky way. We're going to do synthetic division by 4, and that remainder will be the same as what we would get if we plugged a 4 in. So bring down the 9. 9 times 4 is 36. 39, the math gets a little messy here. I've done it already, so I'm just going to put it in here. You can certainly, use your calculator. 39 times 4 will give you 156. Add those up and you get 158. 158 times 4 will give you 632. Add those up and you get 628. Multiply 4 times 628 and you get 2522. Add those two numbers up and you get 2544. That's what the answer is, 2544. So f of 4 is 2544. If we take this equation and we plug in a 4 everywhere it says x, we will get 2544. You can stop right there, but let me show you that that is true. F of 4 equals 9 times 4 to the 4th plus 3 times 4 cubed plus 2 times 4 squared minus 4 times 4 plus 32. So f of 4, when we plug it in, we're going to get 9 times 256, which gives us 2304. We're doing 3 times 64, which will give us 192. We're doing 2 times 16, which will give us 32. Negative 4 times 4 is minus 16. And add in that 32. And f of 4, if you add all those together, you're going to get 2544, as promised, by using the remainder theorem and synthetic division. So this is asking you to do synthetic division, which you're totally comfortable with, and noticing that the remainder is the answer. F of 4 equals 2544. If you feel like proving it, you can prove it. Okay, I'm going to move my paper up for a second, so give myself a little bit more room. And let's see what I got here. Okay, number 11 is asking you to use the rational zero theorem to list all the possible rational zeros for the given function. So we've got f of x equals negative 2x to the third plus 4x squared minus 3x plus 8. Remember, in order to find all the possibles, this doesn't mean all these work, but what we're doing for the possibles is we're creating a fraction where on top we're putting all of the factors of this guy on the end. So 1, 2, 4, and 8, that's everything that goes into 8. Here, the factors of 2 are 1 and 2. So all our possible zeros, and not all these might work, but some of them might. We'll explore that in other problems. Remember, we're going to say 1 over 1, and then we're going to say 2 over 1, then 4 over 1, and 8 over 1. So plus or minus 1, plus or minus 2, 4, and 8. And now we've used up all of these numerators with that denominator. Now let's go through and use up this numerator with that denominator, etc. So 1 over 2, that's a new one, 1/2. 2 over 2, that's 1, we've already got it. 4 over 2 is 2, we've got it. 8 over 2 is 4, we've got it. So there are all the possibles. They won't all work, but we'd assume a couple of them will work. We know we got 3 zeros in there, so not sure which ones would work. Don't care on this problem. Number 12 is asking you to do the same thing. Come up with all of the list of all possible rational zeros for 7x to the third minus x squared plus 3. And again, the numerator will be the factors of 3, plus or minus, not yet. 1 and 3 are the numbers that go into 3. The denominator, 1 and 7, go into 7. I'm back. Okay, so now what we're going to do is do the same thing. We want to do 1 over 1 and 3 over 1 with a plus or minus. So those are two possible zeros, a plus 1, a minus 1, plus or minus 3. And now let's go ahead and say 1 over 7 and 3 over 7. And those are all the possible zeros that we could have for that function right there. Okay, number 13 asks us to use the rational zeros, find them all, and then use them, figure out what works. So one bigger step on this problem beyond what we did in number 11 and number 12. Minus x minus 3. So when we're looking for zeros, the numerator will be 1 and 3. The denominator is just a 1. So our zeros are plus or minus 1 and plus or minus 0. That's what we can, plus or minus 1 and plus or minus 3. Those are the ones we can try. And so, let's try 1. I don't know. Let's look at what we've got here. 1, 3, -1, and -3. 1 times 1, add them together. 4, that gives us 3. 3 times 1 is 3. That zeroes out. Good, that worked. That's going to be a good zero for us, so we're going to use it. So 1 is a 0 in this equation. That leaves this equation, x squared plus 4x plus 3 equals 0. We need to factor it. Now that it's down to x squared, you're capable of factoring it. Sometimes we'll use, old-fashioned, just factor it in 2 sets of parentheses. Sometimes we'll have to use quadratic. We'll do that later. So let's see what we got. Let's put x's in the first spots. You see you got that positive sign there, so the signs need to match, and they'll both need to be positive. What two numbers multiply to give you 3 that add together to give you 4? It's 3 and 1. And so there are our other two zeros. Set these each equal to 0. If you need to do that, move it over. X equals -1. X equals -3. And don't forget we already had a 1, so x equals 1. So there are 3 zeros for this equation, 1, -3, and -1. And I want you to notice that even though we found the 1, there he is, plus 1, also -3 is here and -1 is here. So if we'd tried any of those numbers, if you had guessed any of these 3, we only have 4 choices here, 3 of them worked. The rest of the problem, the rest of the equation would fall from that. But, you got good odds there of picking one that's going to work. So the question here asks you, find a rational zero with a polynomial function and use it to find all the zeros. So we found 1, and then we used the fact that we found that 1 and got this equation left over to factor and find the other 2. A little bit worried about my time right now. Oh, I'm at 15 minutes, so I'm going to quit this. So this one actually only went from number 7 to number 13. See you next time.